Hello everyone, and welcome. In this video, we'll be diving into the world of Power BI, focusing specifically on one of the most important concepts, incremental refresh. This session is brought to you by ZoomInData, your space for learning business intelligence and data analytics. So, let's get started and understand how Power BI connects to different data sources and why this process is so essential in today's data-driven world. First question: what is incremental refresh and why is it used? Incremental refresh is a Power BI feature that refreshes only newly added or recently updated data instead of reloading the entire dataset. It helps improve refresh performance by reducing the amount of data that needs to be processed during each refresh cycle. It minimizes the load on source systems, especially when working with large fact tables. It provides better scalability by allowing Power BI to manage historical and recent data efficiently through partitions. Second question: what are range start and range end parameters and why are they required? Range start and range end are date or date time parameters used to define the dynamic filtering boundaries for incremental refresh. Power BI uses these parameters to identify which data falls within the historical period and which data must be refreshed. They enable the creation of partitions in the service by helping Power BI segment the data based on time intervals. Without these parameters, Power BI cannot determine the refresh window, and incremental refresh will not function. Third question: what is query folding and why is it essential for incremental refresh? Query folding is the process where Power Query pushes transformations back to the data source for execution. It is essential because incremental refresh relies on the data source to handle date filtering and partitioning efficiently. If folding is broken, Power BI cannot generate optimized queries to refresh only the required partitions. Lack of query folding may force Power BI to load the entire dataset, causing performance issues. Fourth question: at which stage does incremental refresh actually run, desktop or service? Incremental refresh is configured in Power BI desktop but does not run there. The actual incremental refresh process only occurs after the report is published to the Power BI service. Once published, Power BI service generates partitions and refreshes data based on the configured policy. Desktop will only show filtered preview data to keep development lightweight. Fifth question: what licenses are needed for incremental refresh? Power BI Pro supports incremental refresh for datasets up to 1 GB, but it is limited in capability. Power BI Premium, Capacity or PPU, is required for large datasets, advanced partitioning, and real-time incremental refresh. Premium is necessary for features such as hybrid tables and large model storage. Organizations using incremental refresh at scale generally prefer Premium for better refresh performance and capacity control. Sixth question: how does store period and refresh period work together? The store period defines how many years or months of historical data should be kept in the model. The refresh period specifies the most recent window of time that should be reloaded or checked for changes during each refresh. Power BI keeps old partitions static while frequently refreshing only the recent partitions. Together, they balance performance by reducing refresh workload while preserving required historical records. Seventh question: what happens during the first refresh after enabling incremental refresh? Power BI loads the entire dataset for the first time, regardless of the refresh or store period settings. It then creates partitions automatically based on the time intervals defined in the policy. The first refresh usually takes significantly longer due to the full data load and partition generation. After the initial refresh, only the defined incremental partitions are refreshed, improving performance. Eighth question. Which Power Query steps commonly break query folding? Custom column creation that uses functions not supported by the data source can break folding. Merging or joining tables without proper indexed columns may force Power Query to process data locally. Applying transformations such as converting data types too late in the query can also break folding. Functions that transform the query into a non-native format, like referencing lists or using complex logic, typically stop folding. Ninth question. Why must the date filter using range start or range end be applied in the first step? The date filter needs to be applied early so that the data source handles the filtering before any other transformations occur. If the filter is applied after non-foldable steps, Power BI cannot push it to the source, causing folding to break. Early filtering ensures that only the relevant data is processed and imported during refresh. Applying the filter late forces Power BI to load all data locally, defeating the purpose of incremental refresh. 10th question. What happens if the data source does not support query folding? Power BI cannot push the filtering logic required by incremental refresh to the data source. The entire dataset may be loaded every time, resulting in long refresh times and poor performance. Partition creation may not function correctly, as incremental refresh relies on the source to handle time-based queries. In such cases, redesigning the data source or using staging tables or views may be necessary. 11th question. Why would a dataset refresh the entire data even though incremental refresh is enabled? This usually happens when query folding is broken, which prevents Power BI from pushing the range start or range end filter to the source. As a result, the data source cannot restrict data by partitions, forcing a full refresh. If the range start or range end parameters are added but not actually used in the filtering step, Power BI has no reference to determine incremental partitions and loads the entire dataset. Applying the filter after non-foldable transformations also causes Power BI to refresh the entire dataset because the filter cannot be delegated to the source. Incorrect configuration in the incremental refresh policy, such as store period is greater than or equal to refresh period, may cause Power BI to refresh all partitions instead of only the recent ones. 12th question. Why might preview data show empty results after applying range start or range end filter? Power BI Desktop only loads data within the range start and range end window, which is usually very narrow, e.g., 1 day, so your dataset may not contain any records in that tiny range. The preview mode does not execute the full dataset query. Instead, it uses reduced data sampling, which may result in blank previews even when actual data exists. Mismatched data types, for example, date versus date time, can cause the filter to exclude all rows, since date-time comparisons require exact precision. If the filter is applied incorrectly, e.g., using range start is less than or equal to date column less than range end with an empty window, Desktop may show 0 rows even though incremental refresh will work correctly in the service. 13th question. How do you troubleshoot folding not supported errors in incremental refresh? Start by opening the View Native Query option at each step. If it becomes disabled, Identify the latest step that breaks folding and move the incremental filter before that transformation. Remove or modify transformations such as custom columns, merges without indices, type conversions, or complex M functions that prevent the query from folding. Push as many transformations as possible back to the data source by using SQL views, stored procedures, or source-side calculations instead of performing them in Power Query. If folding cannot be restored due to limitations of the data source, consider using a different connector, staging tables, or switching the model to Dataflows Gen 2, which supports different folding capabilities. 14th question. How do you design an incremental refresh strategy for 10+ years of historical data? Set a long store period, e.g., store 10 years of data, and a narrow refresh period, e.g., refresh last 1 month, which ensures that only recent partitions are updated while older partitions remain static. Use yearly or monthly partitioning to keep partition counts manageable. Extremely small partitions, like daily, for 10 years can create hundreds of partitions and slow down refresh operations. Use detect data changes with a reliable timestamp column to avoid unnecessary refreshes on older partitions when historical data does not change frequently. Optimize the data source by ensuring indexes on the date column, enabling the database engine to efficiently filter and process incremental segments. 15th question. Can you use incremental refresh if your fact table has no date column? How? Incremental refresh requires a date or datetime column, so without one, you must introduce a surrogate date column, usually based on record creation or update timestamps. If the source table lacks a date field entirely, create a derived date column from available fields such as transaction ID patterns, log timestamps, or metadata fields. Alternatively, create a staging table or SQL view where a date column is added explicitly for the purpose of partitioning and incremental refresh. In scenarios where no meaningful date exists, incremental refresh cannot be applied reliably, since Power BI cannot determine which data belongs to historical versus refresh partitions. 16th question. How does Power BI create and manage partitions internally? When a dataset with incremental refresh is published to the Power BI service, Power BI automatically splits the data into time-based partitions according to the store and refresh periods. Each partition represents a specific time range, such as a month or year. Power BI manages these partitions internally through XMLA endpoints, where each partition can be viewed, refreshed, or processed independently using premium features. During each refresh, Power BI refreshes only the partitions within the refresh period, while historical partitions remain unchanged, which significantly improves refresh efficiency. As new time periods are reached, for example a new month, Power BI dynamically creates new partitions and may merge older ones depending on model settings to maintain optimal partition count. 17th question. What is partition pruning, and how does it improve refresh performance? Partition pruning is the process where Power BI refreshes only the relevant partitions that fall within the incremental refresh period instead of scanning the entire dataset. It improves performance because the engine does not evaluate or reprocess partitions that represent historical data, which typically remains unchanged. By skipping unnecessary partitions, pruning reduces both processing time and memory consumption, leading to faster and more efficient refresh cycles. Partition pruning is dependent on proper query folding and the effective use of range start or range end filters to ensure the source system can return only the needed data. 18th question. What is detect data changes and when should you use it? Detect data changes is a feature that refreshes only those partitions where data has actually changed, based on a selected datetime column that reflects updates or modifications. It should be used when your source tables are large, but only a small portion of recent data is updated frequently, making full partition refresh unnecessary. This feature works efficiently when you have a reliable column such as last modified date or updated on, which accurately tracks data changes. Using detect data changes helps reduce refresh time even further by refreshing only the partitions with changed records, rather than refreshing the full incremental window. 19th question. What is the difference between incremental refresh and hybrid tables, real-time? Incremental refresh refreshes data in scheduled intervals and manages historical partitions but does not provide real-time results. It relies on scheduled or manual refresh operations. Hybrid tables combine import storage mode for historical data and direct query for the most recent partition, allowing real-time data access without waiting for scheduled refresh. Incremental refresh is best suited for large historical datasets where only recent data changes, while hybrid tables are ideal when the business requires up-to-the-minute data. Hybrid tables require premium capacity, and they introduce an additional real-time direct query cache layer, which incremental refresh alone does not provide. 20th question. How does incremental refresh behave when old data is deleted from the source? By default, incremental refresh does not delete historical records from the model even if those records are deleted in the source, because historical partitions are not refreshed once they are closed. If you want Power BI to remove old deleted records, you must enable refresh history or shorten the store period, allowing old partitions to be dropped during refresh. Another way to sync deletions is to use detect data changes, but even then, only partitions where updates occur within the incremental window will be refreshed. To fully maintain sync with the source, many organizations implement soft deletes with last modified date or create a staged dataset where historical deletions are properly tracked and handled. 21st question. How do you verify partitions using XMLA endpoint or SSMS? The XMLA read or write endpoint must be enabled in the premium workspace to expose the dataset as an analysis services model. Once connected through SSMS or tabular editor, the dataset's table objects and partition folders can be expanded to view the automatically generated partitions. Each partition displays its date boundaries, last processed timestamp, and row counts, allowing validation of the incremental refresh logic. The View Script, or TMSL script option can be used to inspect the underlying partition definitions to ensure they match the configured store and refresh periods. 22nd question. Why do incremental refresh policy changes not apply until the dataset is republished? Incremental refresh settings defined in Power BI Desktop are stored as metadata and are only enforced once the dataset is published to the Power BI service. Any modification to refresh policies alters the dataset schema, requiring a complete metadata rebuild, which the service only triggers upon republishing. The Power BI service maintains the existing partition structure until a new publish operation instructs it to generate partitions based on the updated policy. As a result, changes to store period, refresh period, or detect data changes do not apply to the existing model until the updated PBIX is published again. 23rd question. Why does refresh time increase even if only the last partition is refreshed? If query folding is broken at any step, Power BI may be unable to push filters back to the source, causing all partitions to be reprocessed instead of only the incremental range. Large or overly granular partitions can result in increased overhead because the engine must evaluate each partition individually before processing. Source database performance issues, such as missing indexes or poorly optimized views, can slow down even small incremental partitions. When the Detect Data Changes option is enabled, the system may scan the entire change detection column for the refresh window, adding extra processing time. 24th question. How do you optimize SQL Server, indexes, views, column store, for incremental refresh? Clustered column store indexes can be applied to fact tables to improve scan performance and compression efficiency, reducing overall I/O during refresh operations. Date-based SQL partitioning can be aligned with Power BI partitions to improve partition pruning and reduce the amount of data scanned. Indexed views or filtered indexes on the date column used by range start and range end ensure efficient predicate pushdown and maintain query folding. Heavy data cleaning or transformation should be handled within SQL ELT pattern, allowing Power BI to receive optimized, foldable queries for incremental refresh. 25th question. How do you design incremental refresh for extremely large datasets, 1 billion plus rows? A layered architecture is recommended, where raw data is processed in a data warehouse or lakehouse before being consumed by Power BI, ensuring optimal performance. Monthly or quarterly partitions should be used instead of daily partitions to avoid generating thousands of small partitions that can degrade refresh efficiency. Detect data changes can be enabled to refresh only those partitions where actual changes occurred, reducing the workload on each refresh cycle. Transformations should be delegated to upstream systems, ensuring Power BI's incremental refresh operates on clean, partition-friendly data that supports full query folding. Thank you for watching this session. If you have any questions, you are welcome to contact ZoomInData through our website, email, or phone. We're always here to support your learning journey. See you in the next video.